Lise Meitner? That's her life from November 7, 1878 to October 27, 1968. Meitnerium, originally named unilenium, is the 109th element, and transition metal with 109 protons and 109 electrons with 159 neutrons. Meitnerium was discovered in 1982 by Gottfried Munzenberg and Peter Armbruster with a density of 37.4 grams per centimeters cubed. Meitnerium has an atomic weight of 268 atomic mass units, and it was named after the Austrian-born Swedish chemist who was the first guy to suggest that the radioactive atoms could undergo nuclear fission, Lise Meitner. Having been isolated following the Transformium Wars, there was no dispute over the element's discovery or name. As there were no other suggested names for element 109, there was no ensuing dispute over the name. Peter Armbruster, Gottfried Munzenberg, and their team synthesized the element in 1982 at their lab in Darmstadt, Germany. In order to synthesize the first atom of meitnerium, researchers bombarded an isotope of bismuth, Bi-209, with an isotope of iron, Fe58. The result was a single atom of meitnerium's isotope, Mount 266. The isotope they synthesized has an atomic mass that is 266 times heavier than hydrogen. While not found in nature due to its rate of decay, there are no primordial samples of meitnerium on Earth. The element is a d-block member of the transactinides. Its position on the periodic table puts it in the 7th period, and a member of the group 9 elements. The lack of sample size has prevented researchers from discovering more of meitnerium's chemical and physical properties. Based on the properties of surrounding elements on the table, meitnerium is believed to behave like its lighter homologous element, iridium. It should have similar properties based on its position on the periodic table to cobalt, rhodium, and iridium. There are no stable or natural isotopes for meitnerium. Radioactive isotopes of meitnerium have been produced in laboratory conditions. These isotopes have occurred through intentional fusion of two atoms, or through the observable decay of other elements. There are 15 recognized radioactive isotopes for meitnerium, 8 of which have atomic masses of 266 to 278. Meitnerium's heavier isotopes are more stable than its lighter isotopes. These isotopes have half-lives that are believed to range from as long as 6 minutes to as short as 1.7 milliseconds. Stay tuned for Darmstadtium.